Okay, this lesson is on the derivative, product, and quotient shortcut rules. And the first rule that we're going to talk about is the product rule. And as you know, product means multiply. So I have two things multiplied together, and right here I'm just representing them symbolically in function notation. So I have an f of x times a g of x, and that makes up my whole function. The way that you take the derivative is this little pattern, and I actually say these little words that I have in blue to myself in my head every time I do this. You do the first one, you multiply it by the derivative of the second one, then add the second one times the derivative of the first one. So you have to memorize this kind of little pattern to do this. Alright, so example 1, I have something that really you don't have to do this with. You could actually multiply this out and just use a bunch of power rules. But for the sake of learning this rule, I thought this would be an easy example to work with. And so we'll start with this one. So this is my original function. My derivative equals the first, so you just copy the first one down. And by the way, this is the first piece, obviously, and this is the second piece. It's very clearly marked with your parentheses. So first times the derivative of the second, and I'm going to put that in parentheses because I'm going to have a plus in there. And so this is a power rule, and I would get 4x plus 8, and then the derivative of 5 is 0. So I have first times the derivative of the second. Then by my rule, I'm going to say plus the second, and again, I'm going to write that with no changes, times the derivative of the first. And so the derivative of the first would be this x cubed here, so that'd be 3x squared, and the derivative of 1 is 0, so really that's just 3x squared. And for right now, we're just going to leave it like this, so anybody that looks at it can tell you're doing first times derivative of the second plus second times derivative of the first. Okay, so we have a couple more examples here. We have this one that has our exponential rules, and this is my first piece, this is my second piece. So my derivative would be first times the derivative of the second. And so the derivative of the second means you're using an exponential rule, so 2 to the x times natural log of 2. So that's first derivative of the second plus the second times the derivative of the first. And the first part would be a power rule. So I'd have 14x. So second derivative of the first. Just following that same pattern again. When I get to number 3, before I start, I need to realize that this is the first, this is the second, but I need to think of that second piece as being 3x minus 2 to the 1/2 power, because when I'm getting ready to take the derivative of a radical, I need to make sure that I have it in power form, in exponential there. So now my derivative, first, copy that down, then times the derivative of the second, and again I'm going to focus on this type of notation, so this will be a chain rule. So I'm going to do the outside, keep the inside the same, and then multiply by the derivative of the inside. So this whole piece is the derivative of the second. So first derivative of the second plus the second, not changing that, times the derivative of the first, and again that's just a power rule. So 10x to the 4th. So second derivative of the first. Okay, so example 4 is a good time to pause and you try it, see if you understand what is going on. So I'm going to hit pause, you hit pause, and try this one. Okay, so hopefully you remember to think of this radical as being a power, so e to the x minus 2x cubed to the 1/2. And then I could do, the derivative is first times the derivative of the second, and that's a chain rule, so I have to think about the outside, keep the inside the same, and then multiply by the derivative of the inside, which would be e to the x minus 6x squared. So that was first derivative of the second, then plus the second times the derivative of the first, which would just be 7 in this case. So second derivative of the first. Okay, now number 5 is probably the nastiest that it can get. And the reason is because I have 3 things multiplied, but my product rule only does for 2 things multiplied. And so I have to look at this as a first and a second, but I have 3 things. So the way that I choose to do it is look at this as my first, and then all of this together as my second, which means I'm going to have a product rule inside of a product rule. That is, again, as nasty as it can probably get. So if you'll just bear with it, stay with it, focus on what we're doing. Here's our derivative. Okay, first derivative of the second. So the first is easy, I copy that down. X squared plus 5x. Now I'm going to put a big bracket because I know I'm getting ready to do a complicated thing for the derivative of the second. So the derivative of my second is also a product rule. Don't focus on the outside x squared plus 5x right now. Just focus on these two and the product rule with them. So first derivative of the second would be 12x squared plus 6x plus the second times the derivative of the first. So 1/2 x to the negative 1/2. And then I'm going to close that out. So if you look at the whole problem, I have first derivative of the second, and then the second was a product rule itself. So then I'm going to do plus, and I don't have room, so I'm going to move down here, the second from the original problem times the derivative of the first. And so I'm back over here, so I have 2x plus 5. Okay, now we're going to move on and start thinking about the quotient rule. Quotient meaning that you have a fraction, so we're talking about something divided or a fraction here. And so again, I want to look at my original function as some function on top of another function. That's the original problem. I am dividing. My rule is that I do the bottom times the derivative of the top minus the top times derivative of the bottom, so it's kind of similar to the product rule except we have a minus, but then it's all over the bottom squared. And so again, I actually say that in my head every time I do a quotient rule. Now, I am making a note here, put a big star, and on your paper put do not use for y equals a number over f of x. And what I mean by that is, for example, if I had y equals 3 over 2x plus 1, and the top doesn't have any x's with it. If the top doesn't have any x's with it, I mean, you can do the quotient rule, but you're going to be taking up a lot of space for something that's going to be a lot easier to do a different way. The best way to look at this is as 3 times 2x plus 1 to the negative 1 power. That way you just have to do a chain rule, which is a lot quicker than a quotient rule. And so your derivative would just be negative 3 times 2x plus 1 to the negative 2 times 2. It's just a chain rule. And a quotient rule obviously has a lot of parts to it. So again, when you see a problem and the top does not have an x, it's just a number, turn the bottom into a negative power and use a chain rule. Okay, so we'll move on to some examples, and for number 6, again, I have a fairly basic example to start with for our quotient rule. So the derivative will be, and then I usually put a big line for my fraction. I do the bottom, and I like to keep that in parentheses, times the derivative of the top, minus the top, times the derivative of the bottom, all over the bottom squared. And again, yes, you could do a lot of algebraic simplification here, but for right now and for learning the rule, just leave it like this. Don't try to simplify or reduce. In this form, I can tell what you're doing and if you've made any mistakes. Okay, number 7 is again a fairly simple example, but if you'll notice you have a radical on the top, so you need to remember to think of the top as x to the 1/3 when you're doing this, and then the rule begins. So I have the bottom times the derivative of the top, and again I'm thinking here, so 1/3 x to the negative 2/3. So bottom derivative of the top minus the top derivative of the bottom all over the bottom squared. Okay, and then our last example again is more complicated. This is as complicated as it gets, having this quotient rule here. And I have a product as the top. So that means when I do the derivative of the top, I'm going to have to do a product rule. So anytime you have two things multiplied and they both have x's in them, that will be a product rule. So again, this is similar to that one that we did earlier that was hard. You got to think carefully. So I'm going to start with bottom derivative of the top. So bottom, copy that down. And again, I'm thinking of that radical as x to the 1/2. And this radical is a 1/2 power. So if you need to rewrite, then rewrite. Okay, bottom derivative of the top. I'm going to put a big bracket, and I have a product rule. So first derivative of the second plus, because I'm in the product rule right now, the second times the derivative of the first, which in this case is just 1. Now if you look, what we've done is bottom times the derivative of the top. So I need to come over here and subtract the top times the derivative of the bottom. And that would be a 5x to the 4th minus 3/2 x to the negative 1/2. And then it's all over the bottom squared. Hopefully you have a little more room on your paper than I have on mine. But again, I have top derivative of, bottom derivative of the top is a product rule times the bottom derivative of the, top derivative of the bottom. I'm getting very tongue-tied here. All over the bottom squared. And again, that's as complicated as it can get. Just take it one step at a time and make sure you're covering each rule that is needed. And that concludes this lesson.